how can we do things differently? And why is this important? And we wanted to bring this up because we've gotten a bunch of feedback from the field. We've talked with a lot of clients in the last several months. We've heard about what some of their challenges are, and we want to come up with, maybe some way to address those challenges that they're facing. So what we've heard specifically, time and time again, I've heard, I just don't trust that this historical data, I can't use it anymore, right? So folks are worried that they can't do data science because they don't have historical data to work with because everything has changed, right, in our new normal. And they're worried that if they did use it, it would be inaccurate. Again, lack of trust. And folks have, the impression I've gotten talking to clients is that they feel like they're flying blind and that they have to revert back to kind of the gut reaction, which is the old way of doing things. And they're not really sure how they can move forward. So they're in this weird kind of stasis where, they don't feel comfortable maybe using the data that they have. They're not really sure what they can do. So it's a very uncertain place to be. So what we think we can do to address some of this, and this is not an exhaustive list of things you can do, it's just a handful of examples. So the first thing we can do is think about different approaches to modeling, and I'll talk about what those are. And it's kind of using some oldies but goodies in a different way. Maybe that's a good way to think about it. With regard to the lack of trust in the internal data that folks have, we can explore external data sets to pull in that might make sense. And then, that lack of confidence moving forward, starting small and finding some success. We have I think a good recommendation for how you can actually test something out to see if it helps. So the first thing, some different approaches for modeling or using data science right now. The three things I'm going to talk about here, and I'll break these down, are discontinuity analysis using indicator variables, and then also calculating indexes. And if you're familiar with statistics, you'll probably say, this is nothing new, but I think we can consider using them in a different way, or if you haven't used them, this is the time to use them. So the first thing, the discontinuity analysis, this traditionally has been used for something like a pre-post testing, either in education or healthcare, pharma trials, things like that, where you basically have a point in time, it's the pre-version and then the post version, and you compare them to see if there's a significant difference. And the assumption is you've had some kind of intervention in between. I think from our perspective, we can use this. If you're not actually using the discontinuity approach, like a regression approach with a discontinuity break, at least conceptually think about the break in time. And one of the ways that I think we can do that is comparative modeling. I mentioned this to one client that, we were looking at data from just this year, and I said, well, it would be interesting to look at previous year's data in its own model, and let's compare the two. Let's do this year model, last few years model, and let's see where the differences are. I don't think we need to necessarily throw out all of our historical data, because as local policies change, things are going to open up. People are going to revert back to certain behaviors that they had done before. So, while we're in a new normal for probably an extended period of time, you're going to see pockets of old behaviors crop up. The other reason we want to do this is just because we can compare and actually get a data-driven understanding of what exactly has changed. And that would help you, I believe, determine what levers you can pull. So if we do that comparative analysis, let's actually look at what was and what is, and then what are the things that we can change right here in the what is state. And that will inform some more of the modeling decision making that you can take. So I like this one as a potential method. The other one is indicator variables. These are sometimes called dummy variables. And again, we've used these before, but I used this recently with several clients to indicate the onset of COVID for their particular catchment area or location as a point in time. And that helps us to control for the event onset at the very least. And you can perpetuate that variable over time. Say these are the months where it was in place, or at the very least, this is the point in time where we were impacted by it. It's typically used for categorical data. So things like, gender, season, brand, product. anything that you can codify into a yes or a no, essentially. And that's really the key here. The indicator of interest is a 1. Anything else is a 0. Typically, that's how it works. And I just have another example here. That's kind of a traditional study, how it's been used in the past in the scatter plot, where you can see visually the difference between the characteristic of interest, in this case, the smokers versus the non-smokers, in the outcome. Okay. The third thing here is calculating indexes. And again, this is an econometric principle that's been used forever, but I think we can use this in the current state a little bit differently. So you're basically creating a new scaled value. So the basic formula is an index is the value in the period of interest divided by the value in the base period times 100. So, the base period is, Monday of this week. Period of interest is Thursday of this week. Do the calculation, and that will get you the index number. What are some of the things that we can do that for? Competitor price. Talk to a lot of clients who are trying to keep an eye on what their competitors are doing so they can at least keep up, if not exceed them. So that would be something to take a look at. Doing the price of products. Again, it's very uncertain, so actually indexing that would, I think, provide some interesting insight. Again, from a modeling standpoint, I'd have a little more confidence in the index than the actual value, and that's really the point here, that while the actual value has fluctuated, calculating something in index basically normalizes the data for you within a period of time, so that you're not going to see these wild fluctuations. You're actually looking at apples to apples. Some others, population growth and movement, unemployment, uncertainty, those are things that could also be calculated, and I'll talk about how you can get that information in the next couple of slides by exploring new data. So data sources, we've talked for a long time, last few years, about how you can augment your internal data with external sources, and I think this is actually the right time to consider it if you haven't already. 3 that I want to focus on today, again, not exhaustive. First is COVID-related data. You can get COVID statistics by region, so number of cases, percent positive, trends over time, hotspots. That stuff is public. It's available. It's just a matter of downloading it and then aggregating it. Local policy information, for example, on reopening. If your business is impacted by location, that would be a good thing to incorporate as a data source. Mobility of people. This has been actually really interesting, talking to different clients across industries where people as consumers are really important, and they're seeing movement of people from different locations to different locations than their typical patterns. And so capturing mobility data, and there are different ways to do that, especially from cell phone. Cell phone data is basically the easiest or the best way to do that. But mobility of people can be a really good data element for modeling that can give you a reality check. What are people actually doing today? And then finally, news blogs and reviews. So some of that unstructured data that you might have been interested in before, this is a really good time to revisit that. When I mentioned the uncertainty index, you could actually use that information to calculate the uncertainty, right? If there's an uptick in news articles about COVID in a specific region, the uncertainty index might go up, right? So it's a good way to gain some insight on what's happening. Location-based data as well. Census, again, for people. Consumer data, what are people spending money on right now? Crime information. Crime has gone up in certain areas, so having that information could be important. Demographics, labor statistics and unemployment statistics, points of interest, and risk data. Those are all location-based. And again, it's a reality check. It's the reality of what's happening right now. So it at least gives you insight into what people are doing at this point in time. Finally, spatial temporal data, weather data, which, again, has been of interest for a long time, but again, right now, we've talked to clients who weather is impacting decisions that people are making, right? If they're part of the decision making about traveling, when they're shopping, what they're shopping for. So that's something to consider. So let me just quickly run through some examples here, and I want to give a shout out to my colleague Dale Foreman on the team who created these dashboards of the COVID data. This is coming from the World Health Organization. data. So he has a great dashboard here where daily we can check on the statistics, and we can drill down into different regions to get a better sight into what's happening. So that's one way we could use the COVID data. Location-based data, I just have a snapshot here. I have some segmentation demographic information about a specific area. This is actually New York City. I have crime statistics. And then at the very end, I actually had used this data as part of a predictive model. So those were inputs into my model, but I could also visualize them to understand how they were contributing to the prediction. In this case, it was a pricing model. So this is actually the model that I built. This is the workflow in the modeler streams on Watson Studio. This is the output. And I just have a few visualizations. Don't judge me, Cognos people. I'm not as skilled on the BI front. So these are just some quick visualizations to look at the relationship of some of that external data with my predicted outcome that then we could use to make decisions. And then finally, the weather data, using the weather company API. There are other data sources out there for weather as well, but we have access to the API here. Some of the things that you can look at: actual weather conditions, current conditions, forecasted values, which are incredibly important if you're thinking about what people are going to do over the next week to 2 weeks. You want forecasted information. And then the data elements, I mean, I had a few here. They're really literally endless, but some of the common ones: precipitation, temperature, weather conditions, and I have a few there on the screen to represent that. This is just an example of a Python notebook that shows relationships between data points, and over time we're seeing, between day and night, some interactions there. So great, that sounds wonderful. So we have external data sources, and then we have maybe some different ways of going about doing data science. How do we actually do this? And I would say the recommendation here is to do what we call an MVP. You've probably heard this term before. It's a minimum viable product, where minimum is the most rudimentary example possible. Viable is, okay, let's take it a step further and make sure that it's actually going to work. And then the product is the final version. We're really getting to something tangible that folks can actually try out. So we'd recommend doing that on the data science front, actually building out an MVP, right? Where we can test out what's the minimum point success criteria that we need to hit. So that's really important. We need to identify the success criteria, only include essential features. So it doesn't need to be the full-on use case. It's just a component to test it out, and identify who's going to benefit. So you want to show that prototype to somebody and get their feedback and say, hey, is this worth it? Is this going to give us some good return on our time here? So with that, David, any questions?
We have a couple that we can go through. So first question is pretty straightforward. The data sources that you're talking about, what are the sources? Where can you get these? Yeah,
so again, there are lots of different options out there in the market. The examples that I showed today, the weather was Weather Company, which is an IBM company. Some of the external data, I'm in my model, like the segmentation, the crime data, location data that I used was from our partner Precisely. Again, there are lots of options out there. The COVID data is publicly available from different sources like Johns Hopkins. Local government agencies also have that information available publicly. There's census data that's available from the Fed as well. So I'd be happy to chat more with folks who are interested in those.
Okay. And then, let's say I'm not doing data science yet, and what's the best way to try out some of these new ideas of how to deal with your data and thinking about the data and this new approach that you're describing? What's the best way to get started with that?
Yeah, so doing the MVP, right? And it's kind of, we talked before that cycle with the POT. It's kind of similar, right? Let's just have a conversation about the business problem and start small. Let's identify the business problem, identify some data that you have that we could answer the problem with, and actually test it out and do it quickly, right? Don't do something that you're planning to put in production. Just do the minimum amount to test your hypothesis. And you know, David, we do this all the time for clients. They'll give us a sample data set and we'll test it out, right? You take literally like a week. Let me just go through your data and see what's there. And that could be an MVP, right? It doesn't have to be anything crazy. It doesn't have to be a huge investment.
Okay, I think that's all the questions we've got right now. So thanks very much.
Yep. So just to wrap up here, my section, you know, how can we help? Obviously, we'd love to have a conversation if you're interested in any of these methods, not just from this presentation, but any of the other ones. You know, we could certainly help with a visioning workshop. And if you're interested in doing an MVP, even something simple like we just discussed, we could do that. We have access to sample data sets from some of these external data sources, so we could certainly help you get access to free trials for that. So if that's of interest to you, please don't hesitate to reach out. All right, Don.